Climate change may lead to extreme weather conditions like strong wind, which weaken tree stability. Over 60,000 trees were collapsed in September 2018's typhoon. The need for developing smart monitoring system for large-scale urban tree management is essential to minimizing public safety hazard. The sensor can measure the tilting angles and capture the direction of tree displacement. When installed sensor indicates the angle exceeds the range of thresholds, the system will generate risk alert to designated parties. This acts as an alarm to the responsible departments of unusual tree movement so that the departments can decide to go for effective mitigation measures where necessary. Here is the model simulate how the actual tree movement responds to the wind. The tilting angle and direction of the tree movement have been captured and illustrated on the dashboard. The data transmits to database via low-power wireless networks, LoRaWAN or NB-IoT, that enable the system to visualize the near real-time moving information of the urban trees via dashboard. Comparing to 3G or Wi-Fi, the speed of NB-IoT and LoRaWAN is much faster, and which the information can be shared is much higher, and the latency, the time taken for the data to be communicated between the system and sending device are terrific low. The information packet can transmit to the endpoint in cloud and GIS-based dashboard. The tailor-made GIS dashboard shows lots of significant information, for example, number of sensors in operation and spatial distribution of trees, while the dashboard updates the tilting angle of all trees in near real time. Coupled with the AI stability analysis and big data over the past data capture, we can perceive the possibility of unusual tree limb. The novel monitoring system is considered as the world first applying on the urban forestry management. It has been widely reported and interviewed by the local media, together with the published journal and the article. Currently, the system is adopted by the government where the IoT sensors have been installed on 8,000 trees across the citywide of Hong Kong. We have collected survey data, near real-time tilting data, and the human influence data of how people interact with the urban trees. To get a closer look, a sharp change of tilting and landing direction of fallen tree number 1, explained it was fallen under the strong wind gust in typhoon, and we were told by the system of its unexpected failure at that point. While tree number 2 is OET, which has reported to the government and being under the close monitoring because of the suspect rising trend of the tilt. Sometimes unprecedented tree fall may occur in a typhoon, but the system can inform us the location of tree hazard. For other standing trees, we learned the displacement trend that will bring us a heads up for potential stability issue so we could save the tree in advance. The project funding is vital, and we would like to thank the Hong Kong Jockey Club Charities Trust for continuous support of 32.8 million Hong Kong dollars. Connecting the system to the IoT smart sensing technologies can potentially get to micro decision for the smart city development, understand how people interact with this micro landscape, and develop a holistic smart approach for policy formulation on urban forestry management. We draw the data linkage to inform decision making and future design of the urban landscapes, which enhance the greatest benefits provided by urban trees to bring people closer to the nature.